Okay, we have a very high schedule right now because our senior solution architect from Red Hat, Peter Hall, said that we have lots of things to tell us about MLOps and Kubernetes. So let's welcome him for further ado.
Hello everyone, and good afternoon. My name is Peter Hall. I'm one of the solutions architects at Red Hat Hong Kong, focusing on cloud-native technologies like containers, Kubernetes stuff. But today's topic is more than Kubernetes, more than container. It's really about machine learning on Kubernetes. That's why we have MLOps. So this is a very hot topic right now. And I'm going to give you a very brief introduction in case you are not familiar with what MLOps is. And so let's get started. So for today's agenda, I will be presenting several items. The first one is what really is about MLOps, and also why we need to leverage MLOps at the first place. And MLOps could be run on everywhere, basically, but it could be run on Kubernetes. But the reason why we need to focus on Kubernetes is really one of the items that we'll be talking about. And after that, go into technical stuff. I'll be sharing a tool called Kubeflow, which is an open source project. Not really new, but actually it is still getting a mature state right now. And introducing that kind of thing, including its Python SDK, how you can build a machine learning training pipeline for you to automate and to embrace the MLOps capabilities. And the last part, of course, is the demo. Because I just don't want to say, and then I just don't want to just present, and then you guys just listen, and then say, oh, Peter is just bullshitting around, and then just have nothing to show us. So that's why I'm showing the code. But before I start, I would like to get to know my audience. May I know how many people here are familiar or has been working with machine learning? Can you raise your hand? I guess should be a lot, right? Because this is a really hot topic. Most of the people, I think, using Python nowadays is really not just for web development, but machine learning is one of the key things that people do. But another question is, how about Kubernetes? How many people here are familiar or using Kubernetes? Oh, there are some people. I thought there are none. But that is a good sign, okay? So in short, Kubernetes is a container orchestration engine so that you can scale, deploy containers across a cluster of farms. This is a very, short introduction of Kubernetes. So the first thing I would like to tell is really why to leverage MLOps in the first place. So MLOps is a new phrase nowadays. It's derived from the concept of DevOps, but it's for machine learning. DevOps is really all about application development, infrastructure, right? How to bridge the gap between two teams, right? But now, when it comes to machine learning, there are a lot of challenges. What are the challenges? The challenge here is a lot of people tend to focus on, the model itself, the algorithm, but forget the surrounding items before they launch the model into production. For example, how you're going to collect the data, how you're going to test the model, analyze, verify, do a feature engineering. From an infrastructure perspective, how are you going to manage the underlying resources like a hardware, GPU, in a distributed manner? We're not talking about just single laptop. We're talking about hundreds or hundreds or even thousands of nodes scaled across an environment in order to meet the business needs. And another thing is about the process management. Whether you have a process to manage the approval of the model before you launch, and whether any testing procedures or any verification steps that you need to do for every time before you deploy the model, right? Metadata management. How are you going to track all those models, evaluation metrics? For example, confusion matrix, right? Our secret, and accuracy, everyone score, blah blah blah. So most of the people will say, oh, I just copy and paste, right? And just use an Excel. That's the typical way, right? But this is not the best way. Excel is not traceable, it's not shareable. So do we have a better way? Yes. Infrastructure, serving, deployment. When it comes to deployment, it is not the capability that most of the data scientists are capable to do, because they are not the expert in deployment. But there are challenges. For example, how are you going to scale? How you manage load balancers? How you're going to manage the network security controls, right? Setting security groups, setting etc. That kind of stuff. So these kind of tedious stuff are really time-consuming, and that's why a lot of people fail. They just focus on the code and forget all of this. But in fact, if you want to deploy model in production, you have to care about those. And for machine learning, so these are the life cycle that you need to tackle, right? So from data sourcing, data versioning, into experiment tracking, and for each model you have to do versioning and do deployment. And at the end, of course, you need to monitor to detect. For example, do you have a data drift, right? And do you have any data biases, or whether your AI model can explain? So you want to have an automated way to do all these steps, right? I'm sure you have heard of a new, not new, the very famous paper called "Attention is all you need," right? If you're familiar with data science, if you're familiar with LLM, then you should have all this. Paper, because this paper is the origin of the transformer architecture. But I'm not going to talk about transformer architecture today. I'm talking about the MLOps. I will rephrase the title. Rephrase it, say MLOps is all you need. Why? Just like the reason that I mentioned. In order for you to build an MLOps model, you have to remind yourself, oh, there are some capabilities that you need to build on the platform. The first one is about the notebook environment. For example, if you develop the model, then probably you will train it in a laptop, right? But this is not a scalable solution. We are talking about a lot of data scientists, developers in a shared environment. They need to collaborate. So that's why we need a cloud-based environment so that we can provision the notebook dynamically. We have a controller. After you build the model, you have to maintain a pipeline so that whenever you trigger a retraining, you don't need to do it manually every time. You have a standard way. You have a verified way to make it consistent, just like DevOps CI/CD. For example, in this pipeline, you will do data verification, pre-processing, preparation, and then train the model, and then do evaluation, and then do the deployment. Another thing is about metadata store. Just like I mentioned, please don't use Excel. Please don't just store your models into just a file system. There's a better way. That is the metadata store. So you should have a better UI for you to have a query engine to search, which model that I trained is better, or which model that I trained is doing not good, and then you can compare. You have a visualization dashboard. So that's the metadata store. And for you to store the model, you have to to have some kind of container registry in a container world. But for the model, for AI model world, you have to have a model registry to store all the artifacts that you generate. For example, if you have Omnis file, Omnis format, or TensorFlow file, right? You generate, right? You have to store that in the registry so that you can trace and then you can find or share the resources to other people. Last but not least, it's all about serving. Deployment, and when it comes to deployment, I want it to be serverless. Meaning that as a developer or as a data scientist, I do not need to worry about the underlying networking. I do not need to configure load balancer when I deploy a model. I do not need to query about how to scale, whether my model can hit a resource bottleneck. That is a platform issue. The platform should be able to tackle for us. So that is a serverless concept. So all the things combined together, really make the MLOps shines and help you to foster MLOps culture. But why on Kubernetes? If you think about Kubernetes in the first place, it's designed for what? It's designed for DevOps, right? When you talk about DevOps, there must be some conversation about Kubernetes. So that's why MLOps brings a lot of concept from DevOps. That's why Kubernetes is really relevant. Because first, Kubernetes runs container. Every MLOps job that you run on Kubernetes runs in a container. That means you can maintain its consistency. You don't need to set up a Python environment every time. To verify those dependencies help. And scalability, you can run distributed training very easily together with GPU cards. And portability. Portability is especially useful for industry that are like government or FSI. because they want an exit plan. If someday they are not okay to use one platform, they want to migrate, and there's no vendor lock-in when you use Kubernetes, because you can just redeploy the whole Kubernetes on another platform. And then the operations and all the applications, machine learning models that run on top of the platform remains unchanged. And last, just mentioned, it's born to work with DevOps, so that's why you can bring, if your teams are already embracing DevOps, then it's a very good sign that Kubernetes together can help you to foster MLOps culture. So in order to do that, then you need to have engine. That engine, you can use proprietary, or you can use open source. As Red Hat, we of course embrace open source and also encourage open source technologies, because we are an open source company. And one of the things that we partner is to partner with Google, and then Google tried to open source a project called Kubeflow years back, and then Red Hat came in and then do some contributions to the open source community, and then to shape the ecosystem. So when you run Kubernetes with MLOps, then you must encounter Kubeflow. So what Kubeflow provides is a bunch of features. For example, a notebook controller, provide a pipeline engine, you have a model artifact management, model data store, serving engine. All of the things, all of the items that I just mentioned in the MLOps ecosystem, basically most of them are also embedded in the Kubeflow, so you don't need to worry about. Another thing is about the automated ML. Hyperparameter tuning, automated way, then you can also use Kubeflow. Okay, so this is a famous quote, right? I want to show you a code, and I want to show you how it works in a Python way, because at the end of the day, if you want to build a pipeline, you have to write Python. And to build a pipeline is not a drag and drop. Of course, you can use drag and drop using some plugin tools called Elira. But I'm not going to do that. I'm going to use a code way to show you how you can do that. Right now, imagine you are a data scientist, and I want you to think that you want to achieve 4 of the objectives. The first objective is to build an automated pipeline, like the left-hand side. At the top, I will collect the data and then merge the data. First step is to preprocess the data, reshape the data. I'm sorry about that, the text is a bit small, but that's okay, I'll show you later on. And then build a model, 4 step, and then deploy and then verify. But in an automated way. I script it, and then I can rerun every time in a consistent manner. The second one is about model artifact management. I want to trace, as a data scientist, I want to trace the input, output of each step every time. What data I used to train. And after training, what are the outputs? What kind of hyperparameters I use? Okay? I want to keep track of all of those in a systematic manner. Model metadata management, the third part. Oh, the output may output some of the confusion matrix, or some of the model performance, or you can also record the input parameters. For example, the hyperparameters, the number of batches, epochs, which optimizer are you using. Because again, replace this with Excel. Replace Excel with this one. So the fourth one is about deployment. Whether I want to have a platform so that I can feed in the model, and then the platform itself will give me a HTTP or gRPC endpoint. I can use it immediately. I do not need to figure out how to deploy, how to scale, how to network, how to manage the network, and so on, all the security steps. So these are the things usually a data scientist or developers want to achieve. So how to achieve that? The first one is script, right? There's a Python packages called Kubeflow Pipeline, KFP, and you can import those. The first step is to define something called a component. Component represents a step of your machine learning pipeline. For example, you get the data, it's a step, it's a component. You merge the data, it's a component. You reshape, it's a component. Oh, by the way, no worries. If you want to have the slides, I will give it to you at the end of the presentation. I will give you a QR code. So no worries if you miss anything. So how to do? Just call the create component function and then feed in a Python function to say, oh, what kind of script that I want to run where these steps execute. And for each step, they run in an isolated container. Okay, so that's why you have to feed in the base image, container base image, so that every step they are isolated. So what is the value of isolation? The value is really about things that are not independent in each other. They are modularized. They can be reused, repeatable, decoupled. And also, because it's running in container, it is distributed. They can parallel. They can run in parallel. For example, the first one, if you get the data from batch and also getting the data from real-time source, they can run in parallel. They can have multiple jobs run in parallel and then merge together. So that's why you can build a pipeline in an efficient way. Okay, after you define what components or what are the steps, and then you implement those steps. Okay, you implement those components. For example, I have two components. The first one is about the get data batch. Another one is about the model training. So I have another function called model building, and then you write a Python function to implement those. So how you implement depends on what your model want to train. Just copy and paste your typical data science code to here, and of course you chop it by different functions, and then put it there, and then define some of the input and outputs in the parameter. For example, if I want to get the batch data, I probably will get it from object store. In this case, I'm getting it from bin.io object store, or you can get it in S3 or other object store. And after I get it, I want to have an output. So that's why you define something called output path. Output path is what Kubeflow provides to developers. It's a directory, dynamically generated. And then you can store your output files or any kind of data to there. And then later on, you can use it or trace it back. Okay? And for this one, it's the same. Model building, you have some input parameters, and then you feed in the what kind of data you want to train. I have the training set and testing set data, and then also the training and testing labels. And also you can define the metadata output path. So what are these? Metadata output path are the things that you want to save and display on the Kubeflow UI. For example, the things that I've shown is the confusion matrix. If you want to save the confusion matrix in a visualization way, then you can add a metadata and tell Kubeflow, hey, I have a confusion matrix. Please display it. So you append a JSON string here, and then say, oh, I want the confusion matrix, and the values are come from a CSV, and you just use the panda data frame to convert it into CSV and feed it into the Kubeflow, and then the Kubeflow can display it. Another thing is about, for example, some numerical values like accuracy, model loss, and then you can just feed in the float number, and then the platform will display it. Or you can also save a file. For example, you save the model itself. You can use keywords here, save the model to the output path. This model output path corresponds to the output path object here. The fourth step is to deploy, right? To deploy, you import another package called kserve. Kserve is really the engine that powers the deployment of containers on Kubernetes. So here I specify an object. So if you are familiar with Kubernetes, then you will probably know. So these are really Kubernetes YAML stuffs. And then you specify, oh, this is a TensorFlow model, and then you specify, oh, where is the object's model file being located, and then just save it, and then just run and create it. So after you implement each steps, then you have another function to line all those steps up in a sequential manner to give a sequence. So that's why you define a pipeline using a decorator. And then here I define some pipeline default parameters. And then here I try to execute. Oh, what is the step 1.1? I try to get the data from batch. What is the input? And then the 1.2. What are the input outputs? And then you can define the sequence. For example, steps 2 should be run after 1.1 and 1.2. Then you define it here. So that's why you have I mean this relationship. 1. Here, 2, so these are dependency that you can define. The last one is to compile the pipeline. After you define this function, you basically go and execute this compile method, the function. What it will generate is a YAML file. We don't need to care about the YAML file content, and then you just need to upload this file content to Kubeflow, and then give it a version number, and then you can execute the pipeline in a consistent way. Okay, let me just do a very quick, demo here. I have like 5 minutes of time, and then before I wrap up. here's the Kubeflow. So I have already installed Kubeflow engine on one of the Kubernetes. So this is the UI. So here I can go here and then start a notebook, and then just connect. And then I already have the pipeline script defined. So I'm not going to read line by line, but I just want to let you know, oh, these are the things that I have shown. Or for example, how you implement the component, the steps, how to get batch data, right? Getting data from inio and then split the data, etc., etc. And then try to use the JSON file to, the JSON to save the metrics, to say, oh, how many training data and testing data I have. And then the second thing is to merge the data and have another function, but not really merge it because I'm trying to pass through here, but just anyway. And then do the reshape. We have a third function called reshape, so it receives an input from the previous step and then output to another step, output path, input path. And then you can see, oh, I do some common stuffs, so do the reshape and do normalization, and then save it back to the object store for later use. And then for the model building, I have different kind of hyperparameters input, and then I have different data input, and then also the metadata output. So here I just do some normal machine learning stuffs or neural network stuffs. I build a neural network, and then do a compilation of the model and then train it, use the model feed, and then do evaluations. So what the fun part is here after this one, because the other part is just standard data scientist stuffs. The fun part is here. I want to save the model performance and also the confusion matrix right here. Append a JSON, okay, and then feed the data, the Panda data frames into here as a CSV. Later on, I can display it. And then to serve the model, okay, and then I just go here, and then here's the function to build a Kubernetes object to define, oh, I'm using a TensorFlow model. I am using the objects, the model path that I have trained, and then just do the grades. And the next step is just to do some random verification. I'm going to skip that. After you implement models, so you define the component. Okay, you create instantiate, to each component, and then give the name, and then tell them which kind of container image they're using. I'm using a public AWS ECR container image. Of course, you can use others. And then you do a pipeline, compile the pipeline. So here I can define default parameters. So these default parameters I can change later on when you go to your Kubeflow UI. So this define the input field that you want to change later on. Remember, I have epoch, batch size, optimizer, blah, blah, blah. And then here I can define the sequence. Step 1.1 is calling this function, or this step, getting the batch data. Step 1.2 is getting the latest data, streaming data. And then I try to step 2, merge the data. And then I need to define the dependencies. Oh, step 2 needs to run after 1.1 and 1.2. And then later on, step 3, which is to reshape the data. And then step 3 needs to run after step 2, etc., etc. And step 4, try to build a model, feed in the data. But when you feed in the data, you can see this, you can interlink the input and output between steps and components. For example, if step 4 really depends on the output of step 3, then you can say, oh, the training data here from step 4 is the output of step 3 of a name, right? The training data after reshape, or the label. And step 5 is, survey model run after step 4, and they do verification. So that's all is, as you can see, is human readable. It's not that hard to define. And the last part is to use the main function to execute. And to compile, and then you will generate a YAML file, and then just upload it to the pipeline. So let me just run this, and then give it a name. Python. Okay. After that, you can go to the Kubeflow, and then look at pipeline here, and then you can just click the pipeline that I built. So here's the pipeline that I have uploaded, but it is not run yet. If you want to run it, simply go to the Kubeflow engine, click run, and then select the version. So I'm using the latest version 42, so this is default, already picked it for me. And then give it a grouping experiment. But the main point here is I can change the parameters here for everyone. Remember that in the pipeline, in the function, I define some of the parameters. So the Kubeflow itself is capable to detect, oh, you can change those. For example, I don't want 1 epoch, I want 10 epochs. I do not need to go to Python code to change it anymore. I can just go to this UI and then change, 10. Or for example, my data store is no longer in Min9.0, in some other places, and I change it. And then change it, start. Okay, of course it takes some time, right? And let me show you a success example here. So if I click here, I can visualize a lot of stuff. For example, the getting data in batch, I can see, oh, what are the inputs that I use? Or I'm collecting data from this Min9.0. Okay. But of course, this is not a good practice. To store the security key here, but this is just a demo. You can store it elsewhere. But the output here, what are the outputs after getting the batch data? So it can be stored in the object store, so that you can do versioning, you can do traceability here. And also you can visualize some of the metrics. Remember, in the Python code, we try to tell the Kubeflow, please visualize, so please record this, the number of training rows here, or testing rows here. So this is a place that do the visualization. When you jump into the model building, more visualization can pop up. For example, I can visualize what are the model architecture that I use. I can record those here. You no longer need to use Excel. You no longer need to create a text file or web file to save all of this, to track it by manually by yourself. A system will do it for you. What is the accuracy and performance? And what is the loss? Recorded. You can visualize here. You can trace it back, and also the confusion matrix. I can just scroll here and then click it, and then just take a look at the standard confusion matrix that I have. Because this is a classification model, and this is to detect the digits, right? 0 to 10. So that's why there are 10 categories. Okay, and then serve the model. After you serve, there's another page here called endpoint. You click here, and then what you will get is a URL on Kubernetes. So what Kubeflow does is to set up a container after you train the model, and then deploy it in a horizontal scaling manner, scale it automatically, and then give you something called egress or route. And you can just use this endpoint to call it in a RESTful way, or to call it in a gRPC way. So you don't need to set up load balancing, you don't need to set up networking. All I need to do is just deploy and then consume the endpoint. Okay, so that's all about Kubeflow that I want to show you. And so because I know time is running out, I just have 2 minutes left. But let me just do a very quick warm-up. So the values is really obvious. It's repeatable, right? You can define a pipeline one many times. And traceable, because all the things are visualized on the UI. And a lot of people can just go to UI and take a look, and then all the things are recorded. You can, you can track back the history. And then versioning. Versioning is not something that I've mentioned today, but that is here. Is that you can roll back a pipeline, or roll back a deployment if you want to. For example, your model doesn't work well, you can roll it back. And seamless deployment. I just do some simple coding and then I can deploy model on the fly. I don't need to set up the deployment itself. Okay, so here, because I just want to spend a little bit time to do some advertisement, right? So what Red Hat is doing is really not just about Linux itself. A lot of people think about Red Hat is, oh, you're a Linux company. Yes, we are a Linux company, but we are more than that. In recent years, we are trying to embrace other, cloud-native stuff. For example, Kubernetes. So that's why we have another mature product called OpenShift, which is based on Kubernetes. And platform automations, Ansible, is also one of our key products. But that's not the end of our story. We are moving forward. We are evolving. We are evolving into a platform that helps people to build a hybrid cloud across applications and also AI ML model. So that's why we are rolling out a new service called OpenShift Data Science, which is based on Kubeflow to help enterprise customers to have a supported version of Kubeflow. Because Kubeflow itself is an open source project, it doesn't come with any support. Right now, the OpenShift Data Science has some of the features. For example, we have Jupyter Lab, we have a Kubeflow pipeline, we have something called Code Fair Distributed Training SDK, And of course, we can integrate with GPU, run across anywhere. You can run it on AWS, Azure, Google, on premises, on ID Cloud, etc. Coming up, we have more features to the OpenShift data science. It's like auto data bias, AI scalability, auto registry, and also performance monitoring. And the last one I want to promote is the Red Hat Summit Connect that we are having next week in November 16th at Ritz-Carlton in the ICC. If you're interested, please feel free to do a registration. We have a lot to cover, including OpenShift AI and platform stuff, cloud stuff, automation. So feel free to do a registration. Okay, thank you very much, and I hope you enjoy the rest of the day. If you're interested, then please scan this QR code, go to kubeflow.com. If you want to download my presentation, scan the video one, or connect with me. I'm happy to do so. Here's my LinkedIn. If you have any questions, feel free to ask, or you can pick me up on LinkedIn. Thank you very much.
Thank you very much for that. That's very much a lot of information. So it's a bit over time. Does anyone has a question that I must ask? Or else I'll die. Oh yeah, right. So anyway, if you have a question, just come over here and ask him. It will be glad. And now it's lunch break right now. And be here back at 2 o'clock.